Well, I'll show you. So the 2 pi's on the outside. So, and then negative r to r. It seems like I need to multiply this through, so let me do that. So I get big R root r squared minus x squared minus x root r squared minus x squared dx. Cha, cha. Okay, that's all fine. So now I'm going to split this integral up into 2 integrals, and I'm going to get 2 pi big R times the integral from negative r to r of root r squared minus x squared dx minus 2 pi the integral from negative r to r of x root r squared minus x squared dx. But now, an extremely observant person might notice that, and if you don't notice it, you'll still get the same answer, but you'll just do some unnecessary work. But this entire integral is just 0, because r squared minus x squared is, root r squared minus x squared is an even function, x is an odd function, their product is odd, so that whole thing is odd, we're going from negative r to r. Okay, so that's just gone, and now we're here, and well, what's this? What is the integral from negative r to r of root r squared minus x squared? This is the 3rd time this has come up. That's just the area of a, oh, I forgot that this is only half the torus. So let me just throw a 2 back in there, because I want the full torus. So that's really 4, so that's 4, but the whole thing goes to 0 anyway, and that's 4 too. So anyway, what is this? This integral from negative r to r, root r squared minus x squared, that's just a semicircle centered at the origin of radius r, so that just becomes pi r squared over 2. Pi little r squared over 2. And so, what we end up with is the same thing that we got before, right? 2 pi big R times pi r squared. And I think this is just a far superior and far simpler derivation of the volume of a torus. In some ways, it's just more natural. There's less work. I don't know. Okay, that'll be good enough for now. What's left? 52 and 59. Oh boy. Oh, these are both just like art. All these problems are quite. In addition to this homework assignment being. In addition to this topic being kind of hard, and there being a lot of drawing and thinking involved, and this being an extremely long homework assignment, these individual problems are actually also quite hard. We're just going hard all the way to the end. Okay, 52. 52 says, hey, find the volume of an ellipsoid. Okay, so I guess I can do that. It gives me an ellipsoid, x squared over a squared plus y squared over b squared equals 1, where a and b are greater than 0, and what it says is rotated about the y-axis. Okay, so we're gonna rotate about the y-axis. Well, first of all, let's just guess very intuitively what the answer surely is to this problem. Well, okay, so I have I'm going to draw a small picture. Maybe I'll sort of do it over here and then kind of erase it or something. If I have an ellipse, and that's not so good, but that's a comma 0. That's 0 comma b. I think we did this back in pre-calc C, but it's possible that we were running out of time. I mean, we just never did this. I bet that we did it. I sort of remember maybe not doing it this year. If we are going to rotate this about the y-axis, then no, maybe we did do this. Then what shape is formed? Well, this is going to be a kind of like a zoo. So this is going to be not the football. The football is what you would get if you rotated about the x-axis. The football also kind of looks like a potato or whatever. But if you rotate about the y-axis, you get the curling stone / Mentos piece of candy, or whatever you want to call it. So, what is the volume of that thing? Well, fundamentally, an ellipsoid is just a sphere which has been stretched out in sort of different directions. And we know, because we proved it in a previous video, that the volume of a sphere is 4/3 pi r cubed, which means that the volume of the sphere of radius 1 is just going to be 4/3 pi. So if we think of the sphere of radius 1 as being 4/3 pi, then how is this sphere different? Well, here it gets a little bit subtle. Since it's the A is like more important or something, because since we're rotating about the y-axis, this thing is being stretched out by A in like 2 directions. It's sort of like in this direction you stretch the sphere out by a factor of A, but in the coming out of the board direction you also stretch it out by a factor of A, and in the vertical direction you stretch it out by a factor of B. So if you take the unit sphere and stretch it out by a factor of A, by a factor of A, by a factor of B, we should expect that the answer to this problem is 4/3 pi A squared B. And that's just exactly what we're going to get. Okay, how are we going to do this? I guess with shells. So, got to think for 1 second about what I want to do. Yeah, well, let's just go. I'll draw a sort of quarter, I'll draw a quarter ellipse. Doesn't look so good. Well, whatever. A comma 0, 0 comma B. So I'll think of my region as being this one. And then I'm just going to rotate about the y-axis. So when I rotate it about the y-axis, I get this kind of thing. And it's just going to be my ellipsoid, which is just looking so bad. But okay. I'm going to do this with shells because that seems easiest, because why not? So I'll just draw one shell here, and what happens when that shell gets rotated, it ends up here, and so now I'm going to find the volume of this shell. Well, the radius of this shell is certainly going to just be x, so that's nice. The height of this shell is going to be, well, I have to kind of do this whole thing again, right? I guess I'll just do it over here. So I have to solve for y, basically. So I get x squared over a squared equals 1 minus y squared over b squared. No, I guess I want to solve for y, sorry. So y squared over b squared equals 1 minus x squared over a squared. So that's really like y squared equals b squared times a squared minus x squared over a squared. So really, what is y? It's b over a root a squared minus x squared. Okay, so that is this is just doing some basic kind of pre-calc here, or not even, it's really just algebra, solving for y. Alright, so putting it all together, maybe this is not so bad. I'm going to find the volume of this shell. What is it? It's 2 pi, the radius, which is x, times the height, which is b over a root a squared minus x squared dx. So 2 pi r h dr. That's the volume of one shell, so I'm going to integrate from 0 to a along the x-axis, and that's going to give me like a half of that ellipsoid. So then I'll multiply by 2 to get the full thing. Alright, do I know how to do this problem? Yeah, I guess so, right? Because what am I going to get? I'm going to get 4 pi times b over a on the outside. But then, it's just the integral from 0 to a of root a squared minus x squared dx. Sorry, there's an x in there still. So x dx. Okay, so how do I do this problem answer with substitution? So right here, I'm going to say, okay, let u be a squared minus x squared, and then du dx is then negative 2x, so du is negative 2x dx. And if that's the case, then I need to stick in a negative 2, undo the damage with a negative 1/2, and what do I get here? I get negative 2 pi b over a integral. That is then just root u, so that just becomes root u, and that's du, that was the whole point. But then looking over here, when x is 0, u is a squared, and when x is a, u is 0. So, one last time, I shall flip this, so that becomes 2 pi b over a times the integral from 0 to a squared of u to the 1/2 du. And now, okay, running out of space a little bit, so I'm going to go sideways for a moment. Maybe I'm not running, I don't know. So this is 2 pi b over a times, what's the derivative of u to the 1/2? Of course, you go up to 3/2, so it's going to be 2/3 u to the 3/2. But evaluated at a squared and 0, going kind of fast, but maybe everyone can follow this, I don't know. Okay, so now, when I stick in the a squared, well, what is a squared to the 3/2? A squared to the 3/2 is just a cubed. So this is 2 pi b over a times 2/3 a cubed. And, well, what is that? One of these a's cancel, and indeed we get 4/3 pi a squared b, which is exactly, okay, I erased it, but that's exactly the formula that we predicted that we would get. Okay, so this integration stuff is powerful enough to find the volumes of ellipsoids as well. Okay, let's go. Last problem! Last homework problem of analysis 1A. Pandemic year. 59. This was kind of a bonus challenge. It actually seemed maybe a lot harder than it really was. Here we go. I've done this problem before, but maybe not recently. Let V1 and V2 be the volumes of the solids that result when the plane region bounded by y equals 1 over x, y equals 0, and x equals 1/4, and x equals c is revolved around x over x. Oh my god. Okay. Maybe this is kind of hard. Let's see. Well, let's just do it. Is revolved around the x-axis and y-axis respectively. Okay, well first I'll do the x-axis. So this is going to be V1. So what am I doing again? I am taking the curve y equals 1 over x between y equals 0, so the x-axis, x equals 1/4, and x equals c. Okay, well when I plug in 1/4 into y equals 1 over x, I just get 4. So maybe this needs to be even more like, that's 1/4, and then way up there is 4. And then we have something that looks, you know, if that's 1, then I don't know, something like that. Okay, and then at some point we stop, and we get to the x equals c. So I'm just going to draw c here. Okay, so I believe, if I'm reading this correctly, the region is the region bounded by y equals 1 over x, y equals 0, x equals 1/4, and x equals c. Yeah, I am. So this is the region under discussion. And now, what I'm going to do is I'm going to first rotate this region about the x-axis, forming a certain shape. And then I'm going to rotate it about the y-axis. And the question is, what is the value of c for which these two are the same? Okay, so if I do it about the y-axis, it's just a completely different shape. When I rotate this about the x-axis, I'm going to get this kind of kind of sort of thing. But when I rotate it about the y-axis, I shall get, now that's 1/4, so boom boom, and now this is the same x equals c over here, or whatever. So it's the same region. I'm just going to take a minute and draw this. It's the same region, but now I'm rotating that region about the y-axis. This is shape V2. And well, I'm just gonna get a completely different thing, right? That's 1/4. That's this cha-cha-cha. And what I'm gonna get is this sort of volcano-y sort of thing with a hole in the middle. Okay, so now I'm basically just going to separately solve for both of these volumes and then see for what value of c they're the same. Okay, well, I don't know what the best way to do this is, but I guess here I shall use disks, just because I can. So I draw my representative rectangle, that's x. What happens when that representative rectangle is rotated? Well, I get a disk. And the only thing I need to know about that disk is its radius, and the radius of this disk is just 1/x. Okay, so this is going to be pi, the radius, which is 1/x squared dx. So simple. And I'm going to be integrating from 1/4 to c. Make sure I did that correctly. Yeah. You just have these. You have these circular disks. Every disk has area. Pi r squared times the height. The height is the thickness of the interval. That's the volume of one disk, and we're going from 1/4 to c. Okay, so I'm going to do this integral in a minute. But first, let's go back over here. Now, maybe I'll just use shells. So if I'm going to use shells, then now I have my representative rectangle like that. But the axis of rotation is the y-axis, so for this arbitrarily chosen x value, the radius of the shell is x, and once again, the height of the shell is 1/x. So, in this case, what do I get? I get 2 pi, the radius, which is x, times the height, which is 1/x, times the thickness, which is dx, and I want to integrate from 1/4 to c. 2 pi r h dr. Yeah, so this is like some kind of joke or something, right? Because here we get 2 pi, that's just gone, right? Integral from 1/4 to c of just dx. So this is just 2 pi c minus 1/4. Okay, how about over here, what happens? Well, I don't know. Yeah, so now I have pi integral from 1/4 to c of, well, that's just kind of like x to the -2. So, I mean, this is just also pretty easy. I'm just going to do it. I feel like I'm making some error, but maybe not. Yeah. So the antiderivative of x to the -2 is -x to the -1. Just because. So maybe even just write it as just -1/x or something like that is easier. And then that's c and 1/4, and then there's just like a pi on the outside. So what do I get here? I get negative pi times 1/c minus 4. I factored that negative out, I put it over here. Yeah. So, maybe it would have made sense to just stick it back in. Well, whatever. That's just right. So this is really just pi times 4 minus 1/c. So if I've done this correctly, then this whole problem just boils down to solving this algebra problem. Yo, when is pi 4 minus 1/c equal to 2 pi c minus 1/4? Okay, well, the pi's cancel, and I just get 4 minus 1/c equals 2c minus 1/2. Sort of doubting myself here, but I guess this is fine. And what now? Well, let's just move everything over to one side. So this is 2c plus, well, okay, sorry, 2c minus 9/2 plus 1/c equals 0. Yeah, 2c minus 4.5 plus 1 over c, yeah. Let me multiply through by 2c, so that gives me 4c squared. If I multiply this by 2c, I get minus 9c, and if I multiply that by 2c, I get 2. Okay, so I hope this factors. Does this factor 4, 1, 1, 4, 2, 2, 2, 1, 1, 2? Is it just obvious what to do? Yeah, 8 and 1. So that's 4c1 and c2. And this is just minus minus. Okay, so when do these shapes have the same volume? They have the same volume when c is 1/4, which is just that their volume is 0, but they also have the same volume when c equals 2. And that's just too good. So it's just gotta be right. Yeah. Okay. There we go, guys. Woo! That was the last problem on the homework on shells. This was the last homework, if you were going in chronological order. This was the last new topic that we're learning this year, how to find the volume via shells. So we are done learning and we are done doing homework. This was the end of week 9, and so next week, week 10, the last week of the school year, is going to be just a quiz from the past 2.5, on topics from week 8 and 9, and let me just check this real quick. Yeah, and then you're gonna do that quiz and that's it. School ends Monday, June 15th. If you're all caught up, which is like almost nobody, then the whole last week of school for my class will be just doing this one quiz, which maybe takes like an hour or maybe more. So that's maybe kind of nice. So this gives everyone time to kind of catch up. That's it. This was a wild experience. If you're watching this right now, it means you made it all the way to the end. And we're not going to all be together in a room, and we're not going to have a Zoom call that everyone attends between now and the end of the year. So this is the closest thing to a we're all in the room together having a single shared moment. So I just want to say that yeah, this was just the weirdest thing ever, and hopefully this never happens again the rest of your lives, the rest of my life, although it could be very well all next year like this somehow. But we learned calculus. I think it went okay. You may have found yourself doing even more work than usual because these videos are so freaking long. It seems like I was doing more work than usual. I really just want to commend everyone for staying with it, for putting in so much effort, for just staying positive and staying focused and just having the confidence and the inner strength and character to just keep on going even when maybe you didn't sort of have to from the perspective of your grade. So I think this was a really hard semester. It was for me. I'm sure it was for you too. I did my best. Well, I did mostly my best, and you probably did mostly your best too. So I hope that everything went well. I hope you still learned calculus this way. Maybe some of you even better than normal, and I hope you're prepared for the future and for next year. I hope everyone stays healthy and safe. The COVID thing is still very much going on as of June 5th or 6th, so yeah, be careful. Have a nice summer, do something fun, do something relaxing. I think everyone deserves a little time off to kind of do nothing maybe, and then do something fun that you find rewarding and bring some good to the world. And I will see all of you hopefully back at Blair next year, but if not, we will be in touch. Okay, everyone, goodbye.